Our team dived into the dataset using two approaches. The first approach is user behavior oriented. We want to predict how the users will distribute their time on activities, items, and whether the user invested in actual money. This approach used all three datasets. In terms of business efficacy, this would help a better in-game recommendation for user activities and items, eventually raising user engagement and spending. Second approach is user attribute-oriented. We want to explore the relationship between the user's EVC, PVC, and rank and uses all three datasets. We group users into clusters using k-means and found loyalty groups, a user-player dataset. We want to predict whether a certain user will become disengaged based on user activities. In terms of business efficacy, this approach can be used to reduce the churn rate. We're going to talk about the pre-processing first, and then the user-oriented approach, and then the user behavior-oriented approach.
We have three spreadsheets, but we want to transform into a single spreadsheet that we could use to perform further data analysis. So we apply a data pre-processing approach called sliding window. So we are interested in predicting the user behavior in next J gaming hours based on the data from previous K gaming hour. That's why we apply a sliding window over the daily playtime of each user in their active dates. So in each lookback sliding window, the sum of the daily playtime across all the active dates should be approximately K, and in its corresponding look forward window, the sum of the daily playtime should be approximately J, so that we could extract useful features and targets from the active dates of each pair of sliding window. And so we could apply those calculated features and targets to our machine learning models.
And then we use k-means clustering to calculate the most loyal, least loyal, and less loyal clusters of users. First of all, we summarize the user data by summing up the user daily activity values to have one row for each user for clustering. And then we calculate the silhouette scores to find the most appropriate number of clusters, which is 3. And then we cluster the number of the users into 3 clusters. After this clustering, we gain the insight that with more numbers of days played, the user's daily playtime would decrease, but the user's paid value would increase.
So next, we also use DB scan for user clustering. Different from k-means that uses a distance clustering approach, DB scan uses more of a density-based clustering. And we use DB scan to investigate the relationship between PVC, EVC, and other variables. So first I apply DB scan on the preprocessed data of only 6,000 rows, where each row is based on chronological time window of 10 hours, and also conducted some hyperparameters tuning. And so from the graph, it can be seen that due to data imbalance, most of the data points cluster around zero values with only some small outliers. It can also be seen that the users engaged with nightclub activities have their data points more scattered, with not much of a clear relationship between PVC and EVC, while users engaged in racing have more of a clear relationship. They're spending more on EVC, they tend to not spend much more on PVC. Where the ones spending more on PVC tend not to spend much on PVC. So we can target and influence how racing users access to earn EVC to influence their spending on PVC.
Next, we go to user engagement prediction. I use in terms of methodologies, I split the users into engaged and disengaged groups. The user is engaged if he spent more time after the median date. In terms of the model, we used the XG boost. In terms of the performance, we got a AUC of 0.98. This showed that we could successfully predict user engagement based on variables like activities and success, etc. And then we hope the user attribute information can be used to better understand the user base and reduce the user churn rate.
Then we began to select and build model. We use H2O AutoML to select best model, and the best model turns out to be XGBoost. So we built 3 XGBoost classifier models to predict 3 metrics to answer 3 questions. Which type of activity will the user spend most time on? Which type of item will the user spend most money on? And will the user pay actual money to purchase GTA balance? And then we use Lime. It's an explanation tool to make our model more understandable. You don't want a black box in your business. And by using Lime, you could see that the reason of this prediction, so that it helps to improve transparency and profitability to the business. So that's all of our presentation. For more details, you could check our Jupyter notebooks, which is included in our GitHub submission. Thank you very much.